Alright, so I can't factor something that's k to the fourth. So let's write this k to the fourth as something squared. So I can write k to the fourth as k squared times itself, or k squared squared, minus 1. This looks like a difference of squares, so I can write the minus 1 as minus 1 squared if I want to. So now I have a difference of squares. I can write this as k squared minus 1 times k squared plus 1. Then you need to check each of these brackets to see whether either one of them is factorable. The k squared plus 1 is not further factorable. The k squared minus 1 is another difference of squares. So I could write this as k minus 1 times k plus 1 times k squared plus 1. Look inside the brackets again, see if anything else is factorable, and no. So that's done. Okay, on to the next, 80 and minus 5x to the fourth. So the first thing I'll do is look for a common factor to take out. And both of these terms are divisible by 5. So I'll take out a common factor of 5. Then 80 divided by 5 is 16. And negative 5x to the fourth divided by 5 is negative x to the fourth. Check inside the bracket to see if it's factorable. This inside the bracket looks like I might be able to do it as a difference of squares. So I'll try to write each term as something squared. 16 is 4 squared minus x to the fourth I can write as x squared squared. So now I do have a difference of squares. You get 5 times 4 minus x squared times 4 plus x squared. Look inside each of your brackets to see if they can be factored further. The 4 plus x squared can't, but the 4 minus x squared is another difference of squares. So I could write this as 5 times 2 squared minus x squared times 4 plus x squared. Now that it's in a nice difference of squares format, I can write it as 5 times 2 minus x times 2 plus x times 4 plus x squared. Nothing else can be factored, so there's your final answer. Part C, looking for common factors. Looks like both of these are divisible by 2 and by p, so your common factor is 2p. 2p to the fifth q to the fourth divided by 2p. 2 divided by 2 is just 1. P to the fifth divided by p is p to the fourth. So you get p to the fourth, q to the fourth. Then negative 162 t to the fourth divided by 2p. Negative 162 divided by 2 is negative 81. P divided by p is 1, and you get so 81 t to the fourth. This looks like it might be a difference of squares. So 2p, p to the fourth is p squared squared. Q to the fourth is q squared squared. 81 is 9 squared. And t to the fourth is t squared squared. So I'm just trying to write everything in the format of something squared. I can rewrite this more neatly as 2p times, this works out to p squared q squared in brackets squared minus 9t squared in brackets squared. Okay, now what have we got? Now this is in a nice difference of squares format, so you can write that as 2p times p squared q squared minus 9t squared times p squared q squared plus 9t squared. Look to see if either of these are factorable. This one is not, but your p squared q squared minus 9t squared looks like another difference of squares. So I could write this as p squared q squared. I'm going to write it as pq in brackets squared, and the 9t squared, 9 is really 3 squared, so I can write this as 3t in brackets squared times p squared q squared plus 9t squared. Almost done. So now this is a difference of squares. I can factor that into 2p times pq minus 3t times pq plus 3t times p squared q squared plus 9t squared. And nothing else here can be factored. So finally, you are finished.